Welcome to today's Explainer. Let's just jump right in because today we are tackling what's probably one of the most frustrating, hair-pulling challenges in modern software development, and that is building reliable systems with large language models. We all know the absolute magic these models can produce, right? But when you're actually trying to build production-grade applications, the inherent chaos of AI development can turn into a total nightmare. So today, we're focusing squarely on taming that chaos. We're going to look at the exact tools and strategies that take an unpredictable system and force it into reliable, structured, and perfectly predictable workflows. So, how do you actually tame an unpredictable AI? Well, I want you to think of an LLM not as a standard piece of software, but as a brilliant yet highly erratic worker. On a good day, this worker solves incredibly complex problems in seconds. But on a bad day, they might completely misinterpret your instructions, format their work entirely wrong, or literally just fail to show up because the network dropped. This unpredictable behavior, along with the constant threat of transient failures, is exactly what gives developers such massive headaches. You can't just wrap this in a standard try-catch block and hope for the best. You need very specific tools to harness this erratic power. Here is our roadmap for today. Number 1, the predictability problem. Number 2, handling transient failures. Number 3, forcing structured outputs. And number 4, JSON mode versus schemas. All right, let's start with section 1, the predictability problem, or when brilliant AI workers drop the ball. The core conflict for developers right now really isn't about how smart the AI is. It's about whether or not it's reliable enough to actually put in front of your users. These 4 things you're seeing are massive pain points highlighted directly in the Pydantic AI documentation for LLM-based systems. They call them transient failures. First up, rate limits. You scale your app, you send too many requests, and bam, you're blocked. Then you've got network timeouts, where the model is just taking way too long to think. Third are temporary API outages. Look, even the biggest providers have bad days. And finally, context length errors, where your prompt just simply overflows the model's memory capacity. Every single one of these hiccups can completely crash your application if you aren't prepared. It's a constant battle against unpredictable API hiccups. Moving to section 2, handling transient failures, your automated defense shield. We desperately need a way to handle these network and API hiccups gracefully, ideally without the end user ever noticing something went wrong behind the scenes. And the solution here lies in implementing robust retry strategies. According to the Pydantic docs, you can implement automatic retry logic for your tasks and evaluators. What this actually means is that your code essentially acts as a shield against those transient failures we just went over. Say an API outage happens for 3 seconds, or you hit a sudden rate limit. Your application doesn't just throw a fatal error and die on the spot. Instead, it catches that transient failure, waits, and automatically tries again. It ensures that a temporary split-second outage doesn't result in a permanent crash of your entire application workflow. Predictability step 1 is simply not giving up on the very first failure. Which brings us to section 3, forcing structured outputs, harnessing the chaos. Because think about it, even if your network is perfectly stable, if the AI hands you a beautiful paragraph of text when you explicitly needed a database record, your app is broken anyway. So understanding exactly what a structured output is absolutely crucial. As defined in the Gemini Enterprise Agent Platform documentation, a structured output enables a model to generate output that always adheres to a specific developer-defined schema. I really want to emphasize that word, always. You aren't just asking the model nicely to format things correctly. You are providing a strict mathematical constraint. The model is forced right down at the token generation level to produce a response that perfectly matches your schema. It completely solves the formatting chaos that plagues standard text generation. So how does this actually work in practice? The documentation lays out a beautifully simple flow when using models on the Gemini platform. Step 1, you define your schema. This is often done using Pydantic objects in Python, laying out exactly what fields, strings, and integers you require. Step 2, you pass your natural language prompt alongside this strict schema directly to the model. And step 3, the model generates the data, and your SDK effortlessly parses the return JSON straight back into a clean, predictable object. You literally take unstructured, messy human text, and you force it into clean, predictable software objects. And get this, the Gemini documentation provides a fantastic, detailed example showing that this isn't just for flat, simple lists of data. Structured outputs actually work for highly complex, recursive schemas. They give an example of defining a user interface class, where the UI can contain a list of children, and those children can also be of that exact same UI class.
The model handles these nested, recursive data structures effortlessly. It allows you to generate entire, complex application states in a single, perfectly formatted API call. It's honestly a real game changer.
All right, final section. Section 4, JSON mode versus schemas and knowing the difference. It is incredibly important to know the difference here, mostly because developers often confuse two very different tools when they're trying to get JSON back from an LLM. Let's compare them side by side based on the Gemini documentation. First, you have JSON mode. Now, if you turn this on, the model is constrained to only output strings that parse into valid JSON. And that's great. It ensures the syntax is correct, you won't get missing brackets or trailing commas. However, it does not enforce any specific schema. It might give you valid JSON, sure, but the keys might be named wrong or it might be missing the exact data fields you actually need to run your app. On the flip side, true structured outputs guarantee adherence to a strict developer-defined schema. It doesn't just ensure it's valid JSON, it forces the AI to color perfectly inside the specific lines you drew. It's the difference between asking someone to write a grammatically correct sentence versus asking them to fill out a highly specific tax form perfectly. And what is fantastic is just how accessible this has become. The Gemini documentation highlights that these powerful structured output capabilities are available for all open models operating on the Gemini Enterprise Agent platform, specifically within their Model as a Service, or MaaS, ecosystem. That means you don't have to rely on just one proprietary model to get this level of control. You can leverage the whole open model ecosystem while still maintaining the strict programmatic predictability your code actually demands. So, let's wrap this up. We have seen how automatic retry strategies shield you from the chaos of transient network failures, and how true structured outputs force erratic AI intelligence into highly reliable, complex data schemas. The unpredictable has officially been tamed, which leaves us with one final exciting question for you. With predictability solved, what will you build next? Take these new superpowers, go out there and build some incredibly robust production-ready AI applications. Thank you so much for joining me for this explainer, and I'll catch you on the next one.